Online and noise and online don't go well together. Alright. So we're gonna work through this paper. You're gonna grade yourself. Mark as you go. Learn from your mistakes. Alright. Alright. You're gonna learn from your mistakes. Hello, I'm ready. Remember the pass mark is only 30% now, so everybody should be able to attain that. This is the first one. We'll grow that pass mark eventually to 95%, 90 and 95%. So I'm going to do the paper from the back, from number 10, work my way forward, because people tend to be more attentive at the beginning of the class. I think the questions at the front are a lot easier for persons. So I'm going to start with the questions from number 10 and work to the front. After a while, when I feel more comfortable that you guys are right and so on, then you do the papers from the front, from number 1 and go forward, right? But this is just to start when you guys are more focused and so on. So the intention is to be able to finish this paper by 7:40, so 8 o'clock. I like to finish it by 8 o'clock. It's a whole exam paper we're going through. She's 2 or 40 minutes for you. Come to finish. But remember, I'm not just doing the question and I'm explaining. Talk for yourself. Let's go. This is the first one. I'm not so good yet. When I get good, I'll do them in an hour and a half. When I get good. I'm not good yet. No, not good yet. Alright, let's go. Number 10. Let's not waste any more time. So I'm going on to number 10. And start at number 10. By the way, people online can hear me. I'm here talking. I don't know. People online can hear me. And see the screen. I always have to test that. Who is there? Jadine Smith, can you hear me? And see the screen. You know, let me assume that they can hear me. I think everything is set up how it normally is. So let me go. Alright, number 10, the last question on the paper, right here. Vectors and matrices. Question says we have to calculate this product. Calculate the product of these two matrices. You can see here that we have a 2 by 2. We have a 2 by 2 and a 2 by 3. We plan a 2 by 2 and a 2 by 3. That's a 2. So if I've got a new device, give me problems. Two by 2 times that's a 2 rows, 3 columns. That's a 2 by 3. That's going to be equal to what? So because a 2 by 2, number of columns in the first equal number of rows in the second, those are equal, the multiplication is possible. The result will have the same number of rows as the first matrix, and the same number of columns of the second matrix. So the resulting matrix is going to be a 2 by 3. 2 by 3. Right? That's 2 rows and 3 columns. So set up this to be equal to 2 by 3. 2 rows, 3 columns. Alright? So now put in some x's where the values will go. So we're going to have values here. Where those x's are. So we have to choose the right row and the right column to multiply to get these values. And how you know, for example, what value goes here, or what rows and columns you multiply to get that one, is based on the position. This value is in the first row and the first column. So to get it, you're going to multiply this first row by this first column. And multiply a row by a column the same way. First element in the row times the first element in the column, second element in the row times the second element in the column. Well, let me put a line across here to remind us that we are using the 2 rows in that first matrix. And lines down here to remind us that we're using these 3 columns for our multiplication. So let's go now. So this first value, as we said, is positioned in the first row and the first column. So to get it, we're multiplying this first row by this first column. And we multiply a row by a column. First element times first element, second element times second element. First element in the row times the first element in the column, second element in the row times the second element in the column. So it's 5 times 2 and 4 times 0. 5 times 2 is 10, and the 4 times 0 is 0. So it's 10 plus 0, that first value. Then this second value here is positioned in the first row, second column. So to get it, to multiply this first row by this second column. Same way again. First element times first element, second element times second element. First element times first element, second element times second element. So then, it is 5 times 1 and 4 times 3. 5 times 1 is 5, and the 4 times 3 is 12. And the third value here that we want is positioned in the first row and the third column. So to get it, we multiply this first row by this first column, third column. Same way again. First element in the row and the first element in the column, second element in the row and the second element in the column. So we say first element times first element, second element times second element. First element times first element, second element times second element. So then it becomes 5 times negative 4 and 4 times 6. 5 times negative 4 is negative 20. And the 4 times 6 is 24. So move this out here some more. Alright, so we're gonna go for this position now. That element there, it is in the second row and the first column. So to get it, we're multiplying this second row by this first column. Same way. First element in the root and the first element in the column. Second element in the root and the second element in the column. First element times first element. Second element times second element. First element times first element. Second element times second element. So it's negative 3 times 2, that's negative 6. And negative 2 times 0 is 0. So negative 6 plus 0. Then the value in the middle here is positioned in the second row, first column, second column, second row, second column. So to get it, to multiply this second row by this second column. First element times first element, second element times second element. First element in the root and the first element in the column, second element in the root and the second element in the column. So it becomes negative 3 times 1 is negative 3. Negative 2 times 3 is negative 6. And the last value out here is positioned second row and the third column. So multiplying this second row from the first matrix, third column from the second matrix. You always take the rows from the second matrix, from the first matrix, always take the columns from the second matrix. And so the same thing again. First element in the row and the first element in the column, second element in the row and the second element in the column. So it's first element times first element, second element times second element. So it's negative 3 times negative 4, that's a positive 12. Negative 2 times 6, that's a negative 12. And you can consolidate the values. This becomes equal to, this is 10 plus 0 is 10. This is 5 plus 12 is 17. This is negative 20 plus 4. Same as 24 minus 20 is 4. This is negative 6 plus 0 is negative 6. This is negative 3 and negative 6. That's negative 9. This is 12 minus 12. That is 0. That is the answer right there. Plenty work. 2 marks for plenty work. But guess what? Save 2 marks for everybody doing the exam. Make sure you get it right. Gotta go to that. Next one. State why the matrix, the two matrices are conformable for multiplication. Matrices are conformable when the number of columns in the first matrix is equal to the number of rows in the second matrix. You just have to know that. The number of columns in the first matrix is equal to the number of rows in the second matrix. The multiplication is possible. See it here? See it here? This was a 2 by 2 matrix. See it here? A 2 by 2 matrix. This was a 2 by 3 matrix. See it here? A 2 by 3 matrix. The number of columns in the first matrix is matching the number of rows in the second matrix. That's why the multiplication is possible. The number of columns in the first matrix is equal to the number of rows in the second matrix. Then that's when it is conforming. So just write that. It's conforming because the number of columns in the first matrix equals the number of rows in the second matrix. And that number is 2. That is both of them equal to. That's why it was possible. That's when the matrix multiplication is possible. Alright, gotta go to that. Alright? Next question. Determine the inverse of this matrix. What the inverse now is 1 over the determinant times the adjoint. So the inverse is equal to 1 over the determinant times the adjoint. That becomes 1 over, what's the determinant? It is this product, leading diagonal product, minus trailing diagonal product. So it's products on the elements, and the first diagonal, that's 5 times negative 2, that's negative 10, minus the product of the elements on the second diagonal, that's 4 times negative 3, that's negative 12. That's the determinant. This minus minus becomes a plus. Let's put a positive plus. Let's put a plus there in red. So remember, that becomes a plus. That minus minus is a plus. They multiply that by the adjoint. I will set up the adjoint again. Interchange these two elements on the first diagonal. Just switch them around. So the negative 2 goes up here and the 5 goes down here. You switch these two around. Then you leave these two on the second diagonal where they are and you change the sign of them. So change this 4 to negative 4 in the same place that it was. Don't move it. And change this negative 3 to a positive 3. Same place where it is. Then this under here becomes what? It is really 12 minus 10, that is a 2. Then put the 2 in red under here. So this is really equal to a 2. The 2 that's a 2 under there. That's a positive 12 minus 10, that's a 2. So the final result now is obtained by dividing each of these values by the 2. So it's negative 2 divided by 2 is negative 1. Negative 4 divided by 2 is negative 2. 3 divided by 2 is 1.5. Everyone put 3 over 2, same thing. And 5 divided by 2 is 2.5. If you want to put 5 or 2, same thing. And basically, that is it. That's the inverse matrix. Are you good? Alright, we better get everything right so far now. Don't joke. You must have the thing recorded. I intend for you to go watch the video and over the question then. Alright? Thing is recorded, we only have time to be writing this stuff, all of it. Let's go. Next question. Vectors. Vectors. Remember for vectors, displacement vector, we know the position vectors, it's O times the last minus O times the first. When you don't know the position vector, look at the diagram and see how you go from point to point. Always populate the diagram with all the information that you know. And you're looking for how you go from point to point, travel along the vector direction that you know. That's what it's all about. Vectors at this level really is about moving from point to point. Or you go around the diagram from point to point, travel along the vector direction that you know. Alright? This one says, the diagram below shows triangle OAB, in which OA is a vector R. So you see them put the R right here, so. A lot of people might see this and think it is OC that is R, but the question is saying that it is OA that is R. Everything up here says R. So let's make sure that remember, we put the R over here so I don't forget. That everything is R. Alright, I'm going to take out this R right here, so I don't like it. Take out this R right here, so the diagram. Alright, because that might throw us off. And put a line there. Alright, so the whole thing up here says R. Alright, then it says OB is S, that's fine. OB out here says S. It says, in addition, E is the midpoint of CD. E is the midpoint of CD. So this is the midpoint of this line. Looks like a midpoint, so we can work with that, right? This is right in the halfway point there. And then now, OC is 3/4 of OA. So OC is 3/4 of the whole thing. Now remember, the whole thing is R. It means that the vector from O to C is 3/4 of R. Let's put that on the diagram. So the vector from O to C right here is 3/4 of OA, where the OA is R. So it becomes 3/4 of R. I'm going to put it on the diagram. This becomes 3/4 R. That's what this vector is from here to here. So the whole thing is R, and this is 3/4 R. Then this must be 1/4 R, a quarter R left. But understand that. Populate the diagram. So this becomes 1/4 R. This becomes 1/4 R. Alright, so I can move this now. Alright, so I have 3/4 R and 1/4 R. Then it says AD is 2/3 of AB, so the whole AB down there, so. And they are saying that this piece is 2/3. So this piece is 2/3 of the AB. This piece right here is 2/3 of the AB. And so the remaining piece down there so must be 1/3. 1/3 of the AB. But understand that? Because the whole piece is AD is 2/3 of AB. You want to know those fractions, right? So if you know what AB is, if you know what AB is, then this piece will be 2/3 of that, and this piece will be 1/3 of that. So putting on the information on the diagram. It says, write in terms of R and S in the simplest form an expression for CD. That's this vector we want now, CD. Now we don't know the position vector of D. So we're not going to use O times the last minus O times the first. We know the position vector of C now. The position vector of C is this one. But we don't know the position vector of D. So because we don't know the position vector of D, we're going to use the diagram to help us. So say, how do we go from C to D? Go from C to D, simply. We're going to come up to A first right here, and then go down to D right there. What is the AD? The AD is 2/3 of the AB. But we have not yet calculated AB, but we can calculate AB easily. Why? Because we have the position vector of the A and the B. So we can write up here what AB is. Let's just write up here what AB is. Now AB, based on this information, the AB is OB minus OA. O times the last minus O times the first. The OB is S and the OA is R. So the AB vector is S minus R. So it means that this vector down here is 2/3 of S minus R, but the AB is S minus R. So I'm going to put the arrow on it now. Let me put the arrow on top this one, 2/3 of AB, and just write what it becomes. It becomes equal to 2/3 of this. So it's 2/3 of the S and 2/3 of the minus S. So that's 2/3 of S minus 2/3 of the R. 2/3 of this and 2/3 of the minus R. I say minus S, I mean minus R. So this is what the vector here is. The AD vector is equal to that. Alright? That's what AD is. Let me put it right here. So AD. So the AD right now is going to be equal to that. This vector right here, AD. And this is now 1/3. If you need it, it becomes 1/3 of this just to see. Alright? So based on the diagram now, guys, what we're saying is to go from C to D, let's write out in blue. To go from C to D, we're going to go from C to A first, and then we're going to go from A to D. The C to A is just a quarter R, and the A to D, alright, AB, this should be AD. This is AD. Right, and the AD is this one. So adding those two vectors. So this then becomes 1/4 R plus AD over here, which is 2/3 S minus 2/3 R. So it becomes 2/3 S, that's the only S term there, 2/3 S, and then we need to add these two values now. 1/4 R minus 2/3 R. So a quarter minus 2, you can put in the calculator. We can say, okay, 1/4 minus 2/3. This quarter is the same as multiplying by 3/3, it becomes 3/12. Multiply this one by 4/4, it becomes 8/12. So it's 3 minus 8, it's -5. So this becomes, this and this becomes -5/12. -5/12 R. That's what it becomes. So let me take this off. So that is what your CD is equal to. 2/3 S minus 5/12 R is what CD is. The vector down here. This vector. So remember now, know that we work out CD is like we now know this road. You now know this road now. It is equal to this. It means that you can travel along it. And so you can go halfway of it if you want to see, by taking half of this if you want. As you find a vector, you should be thinking that you know you can travel along the road or travel along a part of the road. That's what you think of the vectors. As you work it out, you should be thinking, okay, I know I can travel along there. I know the vector down there now. Because the question will always set up so that you're going to have to use it next. That's what the questions usually are. See, now they want OE. OE, look at the diagram. Want to go from O to E. That's the position vector of E. So to go from O to E is obvious from the diagram. Come up to C first, and then go from C to E. Where the C to E is half of the C that we just found. Simple as that. Alright? So let's write it out. So to go from O to E is the same as going from O to C first. See there? Going from O to C first. And then go from C to E next. And then go from C to E next. But the C to E is half of the CD that we just found. This C to E is half of the CD. So it's O to C and then half of the CD that we just found. So we need to do this calculation now. The OC is 3/4 R. See here, the OC is 3/4 R. So this is 3/4 R. plus, and then a half of CD is a half of this. So taking a half of that now. Easy. A half of this value becomes 1/3. And the two cancel. So you get 1/3 S. And then a half of this becomes 5/12. 5/24, sorry. 5/12 times half becomes 5/24. So it's minus 5/24 R. That's what half of CD becomes. You take half of this. That's what you get. Alright? And again, we need to consolidate the value. So this is the only S term there again. So that is a 1/3 S. And then we're doing these two now. So we're doing, let's work it out down here. We're doing 3/4 minus 5/24. 3/4 minus 5/24. It's 3/4, huh? 18/24. Good. We can multiply this by 6/6, right? Multiply this by 6/6. So the two denominators become the same. So we end up getting 18 minus 5/24. Because this is 6 3 is 18. 6 4 is 24. So 18 minus 5 is 13. So you get plus 13/24. Plus 13/24 R. And basically that is the answer right there. So some fractions to work. Very good. Why did not good with it? Okay, just taking half of this. Oh, you don't understand half CD? Why is half of CD? You don't understand the calculation of half of CD. I don't understand why I use half of CD. You understand that the CE was half of CD? Good. So we have to do that calculation, and this is the CD that you know. So if you take half of this, you're gonna get this. Half of 2/3 is 1/3. Half of 5/12 is 5/24. So that's it. Right? Anybody else? Are you good? Alright, so that's his answer right here. Next question. Different question for part D. It says the points O, Q, and R have coordinates 0, 0, 5, 2, -1, 4. These are the points out here. Alright? Question says, write in a column vector form the vector OR. OR will have the same values as the coordinates of R. R has coordinates, they tell you up here a while ago, -1, 4. See it here? -1, 4. So since R has coordinates -1, 4, then the portion vector of R, OR, Alright, we're back. So I was saying, we can find the length of that line. That's what this means, you know, the modulus, the length of the line. So we can do it from the diagram. Huh? I'm muted. I'm muted. Oh, I'm muted, that's what I'm saying. Or somebody said I'm muted. I'm not muted. Huh? No, I wasn't muted. Alright. Okay. So we want to find the length of that. So I'm saying that this modulus thing means we want the length of the line QR. That's what it means. Modulus of QR. So we can do it two ways. You can find the length, you can find the vector QR and then use the modulus calculation. Because we have the diagram, we can actually use Pythagoras theorem and get it, the length of the line, by counting the coordinates. So the thing is, what are the coordinates between these 2 points? The horizontal and the coordinates. What are the components, horizontal and vertical components, to get to this vector? So Q to R, horizontally first is this, and then vertically is that. So be careful with the scale, you know. So this scale is every other line is 1. So be careful, right? And vertically again, every other line is 1. So this is really 1, 2, 3, 4, 5, 6. That's minus 6. And this is really 1, 2 up. That's a positive 2. Pythagoras theorem tells us now that the length of this line, this side is 6 units long, this side is 2 units long. The length of this line, the modulus of this line, the modulus of QR, is the length of the line, which is the square root of 6 squared plus 2 squared. I'm not muted. That device is muted. This is not muted. So I'm not sharing it. Not muted. Alright, let's go. So if you want to calculate it, we calculate the QR first. So remember now, OQ is on the point Q being 5, 2. We 5 2 like this. And OR, remember, OR is minus 1, 4. So we're going to use a calculation method to do this. We calculate the QR first, which will be OR minus OQ. O time the last minus O time the first. The OR is this, minus 1, 4, minus the OQ is 5, 2. So it's minus 1 minus 5, that's negative 6, as we saw on the diagram. And 4 minus 2 is 2, as we saw on the diagram. So you see that the vector from Q to R is minus 6, 2, meaning 6 to the left, 2 up, which is what we got on the diagram. Right? So everything consistent. So the modulus of QR, now using these values, will be the square root of the negative 6 squared is the same as 6 squared, and 2 squared is the same as just 2 squared. So you get the same answer. Square root of 40 units is the answer. Square root of 40 units. That's it. Alright? Huh? Why is what square? Because it's part of Pythagoras' theorem. This is length, you know. This is asking for length, you know. This is length. I'm using Pythagoras' theorem. You don't remember Pythagoras' theorem? Alright, on a triangle. Huh? Hypotenuse, that becomes the hypotenuse. Is equal to the square root of this side squared plus that side squared in a right angle triangle. We're using Pythagoras' theorem. So we find in modulus, we are really using Pythagoras' theorem. Understand? So it's not just a formula we're using. It's based off Pythagoras' theorem to find the length of that vector. Right? So it comes from Pythagoras' theorem. Alright. Alright, that finishes that question. One question will finish so far. Let's speed up. That's number 10. Number 9. Let's go, number 9. Well, let me try a different pen. Because this one not working to that. Let me try a different pen. None of them working. None of them working today. Probably gone AWire. Alright, not working. Something on the screen. Touch is off. Anyway, no problem. You press up. What do you want to say? Here. Moving by calculation. If you have negative 6 and square negative 6. Well, no matter, I'm saying to you, it's really a length. So the negative is just a direction. Right? So it's really a length just square. Right? So remember, this is a triangle. Right? The length of this line is this length squared plus this length squared. Square root of that. This length is 6. This length also is 6. It's really 6. The vector is negative 6 because you're going to the left. Understand? But even if you were using the negative 6, here, sir, and you square it, look, even if you decide to use the negative 6, and you square it, plus 2, and you square it, negative 6 squared is still positive 36. Understand that? They don't make a difference. Alright. If you want to use the negative 6, you use the negative 6. They square in the bottom. Negative 6 squared is 36, positive 6 Let me try a different methodology here. It's crazy. No good. Let's try again. Alright, I try another different source. Alright. So I'm saying CXC actually gave 68 degrees on this question. If you notice, I changed it to 74. Because 68 would have been inconsistent. Because this angle is 68. Angle between a tangent and a chord equals angle subtended by the chord. So this angle up here would have to be 68 as well. But then that wouldn't make any sense with this 106. Because total angle on a straight line is 180. So the 106 and the 68 would not add up to 180. See that? So that's why I changed the angle on their paper to 74 to make it consistent. But CXC actually gave 68 on the exam paper for this. So it happens from time to time where they actually make mistakes on the paper. Alright? So I changed this to 74 so that it can work, so that the values are consistent. Alright? The paper that I gave you, this was 74 degrees. Because 74 and 106 is 180. And then this was also 74. Alright? So working the question with a value that is consistent with the diagram. That makes sense. Alright? So the question says the diagram below ECG and F are points on the circumference of a circle. EG is a diameter, that's a diameter. My diameter sub 10, 90 degrees. Right? And it says tangent AEB, that's this one, is parallel to this one. So those two lines parallel, they are connected with this line, for example. So you know that you can look out for your Z angles. You can look out for your Z angles. So for example, this should be a Z angle right here. Come along this line, come down this transversal line, and then go back along this one. Then these two angles now equal, right? Z angles are equal. If you wanted, again, if you come along this line, come down here, and then come along this line, then these two angles add up to 180. These two angles add up to 180. They are co-interior angles, they are angles in the base of the U. So it's going to be 74 to but anyway. Let's continue. Many multiple ways to do the question. Let's just do them in the sequence in which they are asked. Right? And it tells us that this angle is 106. 106. Question says, determine the value of each of the following angles, show detailed working where necessary and give a reason for support your answer. First angle I want is angle ECD. Angle ECD. Angle ECD out here. So I'm seeing that I'm forming a Z down here, so because this line and this line parallel. So I have Z angles. So it means that this angle in here, which is 74, is equal to this angle in here, which is 74. Must be 74. Z angles, alternate angles. You can see the Z there. Good? So that angle is going to be 74 degrees. Angle ECD is equal to 74 degrees because alternate angles are equal to the 74 degrees. And the reason is that alternate because Z angles are equal. Alright, and as you find the angle, put on the diagram. So this angle is 74 degrees. Next angle I want is angle CEG. Angle CEG, where is that now? CEG. CEG, that's here. C to E to G up here. So this angle that I want is right here. But that angle is a part of this 90 degree between the tangent and the radius. That's a 90 degree. Angle between the tangent and the radius is 90 degrees. This piece of it is 74. So this piece of it must be 90 minus 74. Because angle between the tangent and the radius is 90 degrees. So that's 90 minus 74. How much is that? 16? Good. So this angle is 16 degrees. I'm going to write it down here next. So this angle down here is 16 degrees. Alright? So let's write it down here. And so that angle that I want is equal to 90 degrees minus 74 degrees, which is equal to 16 degrees. And that's because angle between the tangent and the radius is 90. Right? See that? Because angle between tangent and radius is 90 degrees. That's the reason, right? I'll show you again. I'll show you one more time. That's a radius and that's a tangent. Total angle inside this is 90 degrees. See that? This piece is 74. This piece must be 90 minus 74, right? So it's 16. Alright, good. Next part says, you now want angle CGF. Angle CGF. Where is that now? CGF. C to G to F is the angle up here that I want. So I now want this angle up here. Alright. How can I find that angle? If I can find this angle over here, right, these two angles are opposite angles in the cyclic quadrilateral. I can use that method. That's not the only method. That's not the only method, but I can use that method. Alright? Yeah, let's use that method. So if I'm going to use that method, I need to find this green angle down here. Now, how can I find that green angle? I said to you earlier that the whole of this angle over here says 106. Why? Because of this Z. This wide open Z here. So because this is 106, and this over here is 106 as well. So that is 106. And this is a piece inside here, so. This is a piece inside here says 74. And the piece remaining in between there, so is 106 minus 74. See that? 106 minus 74. But that's not the whole. This is 106 equal to this one up here, so these are angles. This line and this line parallel. These two lines parallel. Right? So that's a Z angle. So this is 106, so all of this is 106. And so the piece in between here, becomes 106 minus the 74, which is what? 106 minus 74 is what? 32 degrees is that. But I get that. And then now, these two angles are opposite angles in the cyclic quadrilateral. They are supplementary. And so this angle up here that we want becomes 180 degrees minus this 32 degrees down here. So that's not the only way to do it, but Good enough. What that equal to 148 degrees. Alright? That is it. So we're gonna do that work down here. So we tell them about the alternate angle here. So first, so we're gonna tell them, show them how we get the 32 degrees first. So we're gonna first say the angle down here, so what? Angle here, so in between here, so was what? The angle in between here, so is CEF, angle CEF. Angle CEF is 106 minus 74, which is 32 degrees. That's because alternate Z angles, alternate Z angles are equal. We're talking about the 106 angles, they're equal, and part of it was 74. And then now the angle that we want, therefore, the angle that we want, angle CGF, is equal to 180 degrees minus the 32 degrees, which is 148 degrees. And that's because opposite angles in the cyclic, alright, opposite angles in the cyclic quadrilateral are supplementary. Supplementary mean they add to 180 degrees. Alright? That's what happens in a cyclic quadrilateral. That's how we get the 148 right here. Alright, that finishes that part of the question. We'll come to part B, which is our bearings question. I like to set bearings. Alright? It says from a harbor H, the bearing of two ships Q and R are 069 and 151 degrees respectively. So they have shown us the 069, but not the 151. So the bearing from H to R of this direction is a clockwise angle from the north line to here. That is the 151 degrees. That angle is 151 degrees. Alright, so let's put on the diagram. So this angle right over here is 151 degrees. Alright, so it means that in between here then, let's put on in red, becomes 151 minus 69. Somebody can write that out for me, please. 151 degrees minus 69 degrees equal what? Huh? No. No, 82. Right? Tell me the right thing, you know. Don't joke. That's 82 degrees. Alright, so inside here says 82 degrees. You know that from the get go. In case you need it, right? Then give us our distance. It says Q is 175 kilometers from H. Let's put them on. 175 kilometers. So right here says 175 kilometers. And the other distance from H, while R is 242 from H. So from H to R is 242. And I show the 242 there. Alright, so the populated diagram there. It says complete the diagram above to show the information given. So that is it. Put on the 151 degrees, put on the 175 kilometers. Alright? And so we have all that information there. Next one. Calculate QR, the distance between the two ships to the nearest kilometer. So we need to calculate this length here now, this distance. So we have a triangle that we're working in. It's not a right angle triangle. And we have two sides, and the angle between them is 82. So it's that we needed at 82. So we're going to use cosine rule. It's a typical case for the use of a cosine rule to find this side. Alright? So this is, let me put it right here, and then we can move it down. So cosine rule for QR. So remember, I start that part, I was theorem. QR squared equals this side squared plus this side squared. That's 175 squared plus 242 squared. But that's not part of the same. So we subtract a piece. Minus 2 times the 175 times the 242 times the cosine of angle between them. I don't have any space. Let me shift this down some more. Times the cosine of angle between them. That's 82 degrees. Instead of putting the square on this, you can literally take out the square, like a square in both sides, and square root all of this. And just put everything there in the calculator one time. Let me move this down to the next page now. So that's the calculation for QR. Let's put it right here. So we're talking, please. And then QR becomes equal to. Anybody work this out with the calculator? What again? I said to the nearest kilometer, so don't put no point. So let's put 278 kilometers. Alright? And as you find it, you put on the diagram. 278 kilometers. So this distance is 278 kilometers. Alright, this is the nearest kilometer. Anything else we have to do? Question says, calculate how far due south. Due south means towards the south. How far due south is ship R off R by H. The word off here means from. So this off means from. So from H to R, how far south you have to go. That's what it means. Let's show it on the diagram. From H to R, how far south. From H to R, how far south you have to go. So they're basically asking you for this distance. Let me put in purple. They're asking us for this distance down here. And then you put in this east-west line. So the question is asking us for this distance. How far south? So it's asking us for this distance over here. Let's call it X on the diagram. See that? And so we're working in a right angle triangle. That's an east-west line, and that's a north-south line. So this becomes a right angle triangle. So the right angle there. So we can use so-called tower in that right angle triangle. So we need an angle in it. This becomes a hypotenuse in that triangle. That becomes a hypotenuse. This X, this side becomes a hypotenuse. So what will help us is if we can know what this angle is, which is easy because remember now, total angle up here is 151. And so the remaining angle inside here is going to be 151 minus from 180. 151 from 180. 180 minus 151 is the angle inside here. What do I work out to? 29 degrees. Let's try to get it. 180 degrees, total angle straight line minus 159 degrees. 151 degrees, sorry. Is how we get that 29 degrees. And then working in this triangle, we're trying to find the X. You know the hypotenuse is 241. The X is the adjacent in that right angle triangle. So working in the right angle triangle, you can use so-called tower. In this case, you want the adjacent, and you know the hypotenuse. Adjacent and hypotenuse is cos figuration, connect them, right? So we're going to say the cos of 29 degrees in that triangle becomes adjacent over the hypotenuse, which is 242. So to find this distance now, you take this and multiply it across here. So the x becomes equal to 242 times the cos of 29 degrees. What I work out to? That's the distance. When you see a question asks you how far south or how far east or how far west or how far north, you're always working in a right angle triangle like that, yeah? Once you ask you how far east, how far west, how far south something is, yeah, that's where you end up working in a right angle triangle. 212 kilometers. If I ask for how far east, this is the distance that they all want. Because how far east is R from H. That is the distance I will want. How far east? See, to the east. Same as this distance to the east. Right? So this is the calculation. Let's copy it down here. So we are saying that this distance that asks us for up here is actually equal to x. We have calculated x right here. This is x on the diagram. We calculate x. Alright, 2 down, 8 to go. Let's go. Number 8. Number 8 now. Here. It's a linear programming, looks like. Question says, Marla buys 2 types of phones, B Flow and C Flex. Let us say B and C, right? And take out the complication. From a company to retail, she wants to buy and sell. She's buying and selling. One B phone costs $60. Let's write it down. So we have B phone and we have C phone. The B phone is for $60 and the C phone is for $80. That's what she buy them for. Buy them for $80 and $50. She buys X B phones. So the number of B phones is X. Right? So she buys X B phones. So go buy some internet device from thing there. I use my hotspot. Buy some internet device from thing there, and this is what I'm getting. So the man criminal. Let me know. Alright, back, right? This doesn't go up, just this one. Alright. So remember now it's XB phones. Let's write it, XB phones. So X is the number of B phones and Y is C phones. Y is the number of C phones. Y is the number of C phones, right? It says Marla must not spend more than 1,500. She can't spend more than it. She can spend 1,200, sorry, she can spend 1,200 or less. So the total money that she's spending can't pass 1,200. How do you get an expression for the money that she's spending? It's $60 times X for the B phones plus $80 times Y phones, C phones. That's the total money she's spending. That money can't be more than 1,200. It can be equal or less, not more. Must not be more. So it can be equal or less. So the inequality for that one is that 60x, $60 for your phone times X phones plus 80y, $80 for your C phone and a Y C phones. That's 80y. Cannot be more, can be less than or equal to the total money of 1,200. I don't have to put the dollar sign on it. This can be simplified. Divide this through by how much? I put 80y. 80y I must have. $80. Divide through by 20. Yes, everything can be divided through by 20 right here. Divide through by 20. So divide through by 20, this becomes 3x, this becomes 4y, less than or equal to, this becomes how much? 60, right? 60. That is it. 3x plus 4y less than or equal to 60. And we're going to have to put that on a graph, so we understand what it means for the graph. Alright? Next one. The number of B phones, remember the number of B phones is x, right? The number of B phones is x, that's x. Number of B phones, x, must be greater than or equal to, the number of C phones, that's y. That's what they have said. Write down an inequality in x and y to show this information. This is it. X must be greater than or equal to y. We don't like when we do linear programming, our inequality has a y on the right side. One y on the left side and positive, so that the inequality sign will tell us whether we want above or below the line. So I'm going to turn this the other way around and write it instead as y less than or equal to x. We're working with this one because I know the less than means below. Remember, you know, if x is greater than or equal to y, if we read it the other way, then it is saying y is less than or equal to x. We're working with this one in terms of which side of the line we want. We want below the line because it's our less than sign. We're not working with this one. Because remember, for less than to mean below, you want the y value to be on the left side of the inequality and positive. For greater than to mean above, you want the y value to be on the left side of the inequality and positive. So because the y is over here, this greater than don't mean above anymore, it means below. So I turn it around and it shows that it really means below for true, because we get a less than sign. So we are below this line, y equals x. This means below the line, y equals x. Anything else? It says, represent the two inequalities on the grid below and label as R the region that satisfies both inequalities. So let's write them out, what each one means. So this one now, the y over here is positive, so this less than means below. Going below the line. The line is solid or unbroken because the equal is there, so we're drawing a solid line. And the line we're drawing is the one associated with this inequality. You get that line by just changing the equals with an equal sign. So the line we're drawing is 3x plus 4y equals 60. That's the line we're going to draw. 3x plus 4y equals 60. Now, let me show you now again how we get 2 points on this line quickly. Let me do it in purple right here. So we're doing the line 3x plus 4y equals 60, and I want to put 2 points on it. One on the x-axis, one on the y-axis. So the first time I'm going to give it an x value of 0 and use the equation to work out the y value. Second one, I'm going to give a y value of 0, again use the equation to work out the x value. So for this one first, when the x value is 0, it's like you put this 0 right here, and 3 times 0 is 0, then this would all be gone from the equation. Be left with 4y equals 60. The 4y equals 60 divided by 4, you're going to get 15. So when x is 0, y is 15 right here. Good? We do this 100 times already, you know. It's strange there.
I've never understood this.
Look, understand it now. I'm trying to find 2 points so I can draw this line. I have to draw that line on a graph. I need 2 easy points, right? So I've started to write down 2 points. One of them I'm going to make the x value be 0, so that it's going to be a point on the y-axis. The other one I'm going to make the y value be 0, so it's going to put a point on the x-axis. You get me? To find the x value find the y value that is coming here, all I need to do is substitute this x value in the equation for the x there. So, you understand that? When I put a 0 for the x value, the 3x is going to be gone because it's going to become 0. 3 times 0 is 0. I'm going to left with 4y equals 60. When 4y is equal to 60, I divide by the 4, the y is going to be 15. You understand that? So when the x is 0, the y is 15. Then I do the same thing over here. For this point, I now have the y value equals 0. So I'm going to take this 0 and substitute for the y value here. When that y value becomes 0, this 4y is going to be gone, because 4 times 0 is 0. I'm going to be left with 3x equals 60. If 3x equals 60, I divide by the 3, it means that the x becomes 20 at that point. So then these are 2 points on this line that we can draw easily. Alright? So it's a quick way to do this thing. To get 2 points on a line. Alright, so I'm going to put these 2 points on the graph. Then for this one, this one easy. That's just the line y equals x. That's just the line y equals x. And the less than now means below, because the y is on the left side and positive. So this one is below. It's a solid line again. Why is it solid? Because the equal is a part of inequality. If this equal was not there, and it was just less than alone, they would draw a broken line. Meaning that the line is not a part of inequality. And the line we draw and associate with this inequality is the line y equals x, which is like the easiest line to draw in maths, because it passes through points where the x and the y values are the same. 0, 0, 1, 1, 2, 2, 3, 3, points like that. Pass through points where the x and the y values are the same. So basically drawing this line through those 2 points, and this line passing through points where the x and the y values are the same. So let's go. On the graph. So we say 0, 15, and 20, 0 need for that line. 0, 15. I think the scale messed up to it now. Now I think I remember what this scale is. Scale is messed up. Scale is messed up because look here, there are 1, 2, 3, 4 intervals for 5. Right? And then up here, they have 1, 2, 3, 4, 5 intervals to go from 15 to 20 for 5. So the scale is kind of messed up. Look, boy, pay attention now. You get me? So, if I'm in the exam, I'm going to correct this. I'm not going to leave it like that. I'm going to work with a different scale and change it. Alright? So, because if you draw it just like this, it's going to be messed up. Because the 20 down here, for example, 20 down here, if this scale is correct, they're using this scale as a correct scale. Alright? Then, here's where the 20 should be, right here. Alright? So is that I want to leave it there, change this and put the 20 right here and take this out. And put 20 right there and just work with that scale. Alright? Let's do that. So I'm going to draw the line 0, 15 and 0, 15 and 20, 0. 0, 15 and 20, 0. So 0, 15 is right here and 20, 0 is down here. So you use a ruler now and draw a straight line through those 2 points with your ruler, right? 0, 15 is on the y-axis, 20, 0 is down here. So you draw a straight line through those 2 points, something like that. Alright? And the other line you draw is the line y equals x. Remember one below this line, right? So below this line, one below. So I'm putting an arrow pointing down. Remember that I want below this line. And label the line with the equal sign. What was it again? 3x plus 4y equals 60. Yes, 3x plus 4 equals 60. This line is 3x plus 4y equals 60. Then now the other line is line y equals x. It's passed through 0, 0, passed through 5, 5 right here. It passed through 10, 10 up here, so. And so on, right? It passed through 15, 15 up here. That's the line y equals x, right at the middle of the graph, right there. Let's try it again. Label the line with the equal sign as line y equals x. And you want to go below this line. So the reason that you want, guys, is below both lines, below here and below here. See that? So the reason that you want is inside the space. What I'm supposed to shade it or label it? Let me say label it or shade it. Or label the R. So the region that you want is down here. So put the R down there. So that's the region that satisfies inequalities down here. So. What is that? What good? Alright. The next part now says total number of mobile phone represents X plus Y. X plus Y is the total number of mobile phone. Remember it was XB phones and YC phones, right? It says, according to the graph on page 12, what is the largest possible value of X plus Y? When you want to find maximum or minimum of anything, you go to the vertices. Go to the vertices. X plus Y. So you go to these vertices down here. We use a different color. Right? I can use it. This is one vertex down here, so. It's another vertex down here, so. It's another vertex right there. So this vertex is cleared out of it, because that's 0, 0, right? So it's between these two. What we know about this one down here? We know that down here, so x plus y is 20. I don't know, so it's 20, 0. So down here, so x plus y equals 20. X plus y is equal to 20 right here, so. Good? Watch this now. This point, remember this point, x and the y value is the same now. X plus y now equals 20, because it's 10, 10 here, so. It's a 10, 10. See that? Here, so x plus y value equals to 20. So right here, so the x value and the y value both less than 10. So right here, so x plus y is actually less than 20. So x plus y is maximum at this point right here, so 20 0. But that's the answer that. Alright? Not here, so. Alright? I kind of not trust it because they never give me the right scheme, but it's clearly less than 10. Right? Clearly less than 10. That's a 10 here, so it's a 10 10 on this line. So this point is not 10 10. Remember now, you're on this line, you know, so the x and the y value is the same right here, so you know. X and the y value is the same right here. And both of them less than 10. So them can't add up to 20. The maximum value of x plus y is right at this point down here. That's where x plus y is maximum. 20. So maximum is at 20 0. At the point 20 0. That's where it is maximum. But good? Alright. Next question says, the table below shows pairs of values of the function y equals x squared plus x minus 4. That's a quadratic function. Remember, a quadratic function is a symmetrical function. The y values are symmetrical about an axis of symmetry. And you can oftentimes see the symmetry in the table as well. So if you look at the y values to see the symmetry. So the y values here, those two values are the same. If you go outwards, you go to a -2, outwards, you go to a -2. You go outwards again more, you reach a 2. You go outward again, you reach a 2. And then continue out again, you reach a 8. Continue out again, you reach a 8. So the line that these values are symmetrical about is this line right here. See, the values are symmetrical about that line. See that? This line represents your axis of symmetry in the table. What will be the x value on that line? That line is right in between -1 and 0. Halfway between -1 and 0. Halfway between -1 and 0 is -1/2. So this line would be where x equals -1/2, right here, so. X equals -1/2. X equals -1/2. So I can tell from now that that is my axis of symmetry. X equals -1/2. And if I want to find the y value corresponding to x equals -1/2, now start answer the question, but I'm telling you these things. If I want to find the y value where x equals -1/2, that's at the vertex. Remember, the vertex, the turning point, is on the axis of symmetry. And that's going to be your minimum value, your lowest y value on the graph. But the graph going to come down, the axis is right in the middle corresponding to this. The y value here can be obtained by plugging in this x value in the function. So if I plug that minus half in the function, it will tell me what that y value at the minimum point is, which we call yt, y value at the turning point. See here? Y value at that turning point. This is xt now. This is actually xt. X value at the turning point, at the axis of symmetry. Right? So to plug the minus half in this, it's going to become y equals minus half squared plus minus half, what is x here, so, and then minus 4. Put that all in the calculator and work it out, what are you going to get? That's a quarter minus half and then minus 4. So this is like 2 over 4. So that's minus 4 and a quarter. Minus 4 and a quarter. That's what we go to. But this one is same as 8. It's for same as it's for that 16 over 4. Yeah, minus 4 and a quarter. That's minus 4 and a quarter. So your minimum value, lowest y value is minus 4 and a quarter. Right? Minus 4 and a quarter. We can work out using xt, yt simply. Alright, 4, 4 is 16, 16 and 1 is 17. That's negative 17 over 4. So we work out yt using the formula method, that's what we're going to get. Minus 17 over 4. But anyway, let's go. That's just information we can pick up from the table without even doing any work yet. So your minimum point has these coordinates. Minus a half, minus 4 and a quarter. Because we're using the fact that the values are symmetrical about an axis of symmetry. Alright, it says rather the maximum or minimum value of the function is this, you know. And we know it's a minimum, so we can cross this out. We know it's a minimum, so we can cross this out. How we know it's a minimum? Because the A is positive. When the square term is positive, we have a small shape and a minimum point where we have a minimum value. So we know it's a minimum value. Now if we were to calculate it using our formula method, yt, remember the formula method? Yt is 4ac minus b squared over 4a. So if what I explain up here is true, then this is supposed to work out to the same thing that I have up here. So let's work it out. 4 times a. In this expression, the a is equal to 1, the b is equal to 1, c is equal to negative 4. That's the coefficients in there, right? That we are using to calculate the yt down here. 4ac minus b squared over 4a. You have to remember these things. So it's 4 times 1 times the c is negative 4 minus b squared. That's a 1 squared minus 1 squared divided by 4 times a, where the a is 1. See there? This is negative 16 minus 1 become negative 17. See that negative 17 over 4 times 1 is 4. Same answer as that. Same answer as that. That is the minimum value. Y value at the turning point. Alright, 1 mark for that. Next one. Using a ruler, draw the axis of symmetry on the curve on page 25. Oh, they wanted us to plot the curve. I never do that yet. They wanted us to plot the curve in part 1. I didn't see that. So I had to draw the curve. So they gave us the points. We have some of the points. I'll put in the rest of them. I'll put in the rest of them. Now, the first thing we have to remember now is that this is negative 4 and a quarter. It's minimum point. It's negative half, negative 4 and a quarter is the minimum point. So I'm putting that point down here. So negative half here, negative 4 and a quarter. So negative 4 and a quarter will be right here. That's 4 and a quarter now. This negative 4 and a half, negative 4 and a quarter about here. So. Right? So that's where the graph will turn right there. Graph is turning right there. Huh? Okay, negative 17. Which one of the calculation? The first one or the second one? What you get? It's a negative 16, right? This set of circle is negative 16, that right? Minus, this is 1 squared, which is 1. Negative 16 minus 1. The squares on this one alone. Where you put it? You put it in exactly like this? Yeah, we can come and see. I want to see what you put in wrong. Quickly. We're using this foolishness and you have the bossy calculator and you're trying to do all of that foolishness. Do this. 4 times 1 times negative 4 minus 1 squared. Why don't we just the power of the calculator over 4 times 1 equal. You have the good calculator and the foolishness with it. Oh, you know. Alright. Use the full capacity of the calculator. Alright? And don't wing it. Alright, let's go. Alright, so we need to put in these other points, guys. We need to put in these other points, alright? So the other point is gonna be we can use the symmetrical nature of it, because that's gonna be an axis of symmetry, this line. The values are symmetrical about this line, those y values are symmetrical about this line. And the graph turns here. Remember, the turning point is right here. Negative 4 1/4. That's negative 4 1/2. Negative 4 1/4 is about right here. So the graph is going to turn right here. Right here. Then these values are symmetrical. So there's a line, there's a point exactly the same distance across from here, which is here. See? That's 0, negative 4. Let's look at it. 0, negative 4 is a point on the graph. See there? 0, negative 4. You have 1, negative 2. Same distance across from this. This distance is what? 3 units there, so 3 units across. 1, 2, 3. See there, so 1, negative 2. That's a point. So you can even use symmetrical nature of the graph from this. Look at this one. This is how many units to the line. 1, 2, 3, 4, 5. Is a point 5 across from it. 1, 2, 3, 4, 5. Because the thing is symmetrical about this red line. Another point, you have a point up the top here, so it's the same line of axis of symmetry. X equal minus half, this line. So this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There's a point over here. Those are the points. They draw a smooth curve through those points. Close the door, please. Young girls, when you go out the door, no, don't close the door. You draw a smooth curve through these points. That is it. What did I draw through the turning point down here? Alright? That's my curve. Next question says, using a ruler, draw the axis of symmetry. See it here? This red line is the axis of symmetry. X equal minus a half. Axis of symmetry. X equals minus half. Y values are symmetrical about that. That is it. Alright, question done? Yes, this question done. Alright, draw the axis of symmetry. Axis of symmetry is x equals minus half. Draw. Alright, that done. Number 7. Let's pick up the pace now. 7 more to do. 6:45. Alright. Question says, figure 3. First 3 figures have a sequence of shapes formed by connecting lines of unit length are shown below. Draw the fourth figure. So we did this question the other day, so we can do it again quick and fast, right? So you can realize that I keep adding one of these shapes. Alright, so to draw the fourth figure, I can draw about this shape and then copy one onto it. So let's draw about this shape. Start my fourth figure. And I can move this one onto it. Something like that. Now move on everything to the right. And that's my figure 4. Got it good? Nice and easy. Next part now says, the number of lines L in each shape and the perimeter P follow a pattern. It says, study the pattern of numbers in each row in the table below and answer the questions that follow. So as I said, we like to fill out the formula line first by picking up on the pattern of the number. So these values are increasing by 5. So the formula starts out with a 5n. But the first value is 6 where the n equals 1. Where n equals 1, 5 times 1 is just 5. So we need to add 1 to make it equal to 6. That becomes the formula for that column. Here, the values are increasing by 3. So because they're increasing by 3, the formula starts with 3n. But the first value, where n is 1, is a 5. 3 times 1 right now is only 3, so I have to add 2 to make it equal to the 5. So that becomes the formula for that column. Alright, now that that is the case, we want to find out for this row, where n is 5, put 5 on the formula there, so 5 is 25 plus 1 makes 26. Alright, it becomes 26. It becomes 5 times 5 plus 1. That's 26. And then you can put 5 on the formula right here again. You get 3 times 5 is 15 plus 2 is 17. See here? 3 times 5 plus 2, that's 17. Then on this row, we know that this is equal to 66. So we'll put this formula equal to 66 to see what the n is. Let's work it out right here. In there, 5n plus 1 is equal to 66. Subtract the 1 first, you get 5n equals 65. Then divide by the 5, n equals 65 over 5, what that equals to 13, n equals 13, right? So, yeah, 13. So this is 13. Now that is 13, when I take this 13 and drop it on this formula to work out the figure for here. So it becomes 3 times 13 plus 2. This becomes 3 times 13 plus 2. 3 times 13 is 39. 39 and 2 is 41. That becomes 41. So that is the table completed. Nice and easy. Down here says, write a simplified expression in terms of n for the difference d between the number of lines and the perimeter. Remember the number of lines, L is 5n plus 1, and the perimeter is 3n plus 2. So it's 5n plus 1, the perimeter is 3n plus 2. We want the difference. The difference d becomes L minus p, which becomes the L is this expression, 5n plus 1, minus the p is this expression, 3n plus 2. Just be careful with this negative sign now. So it becomes equal to 5n minus 3n, that's 2n. And then 1 minus 2. 1 minus 2 is negative 1. That becomes the formula, 2n minus 1. the difference. That is it. All right, that's number 7. Let's go on to number 6. Run through these 6 quickly. Seems say more and say all this question I'm gone. This question says, Farmer Brown makes troughs to feed his farm animals using wood of 5 centimeters thickness. It says, as shown in the diagram below, the trough is rectangular base, open at the top, and has external dimensions 200 by 190 by 160. Remember, this is 5 centimeters thick throughout. So the material up here is 5 centimeters thick. The question asks us, show by calculation that the internal capacity is this. That's the internal capacity. So to get the internal capacity, we need the internal dimensions. Let me put in internal dimensions on this diagram now. So firstly, this external length is 190. You're taking off 5 off of this side and 5 off of this side, so you're subtracting 10. So internally, this length becomes 180 centimeter. But understand that? But understand that? Then across here, let me use a different color for across here. Across here, externally, the length across here is 300. But again, you're taking off 5 from this side and 5 from this side. So internally, this is now 290, subtract 10 overall, so this is now 290 centimeters. Then you have the depth of the box. Let's put the depth of the box in purple down here. So. Now the thing about this side though, is that the top is open. So the thickness is only at the bottom. So this, for the depth now, you're going to only subtract 5 at the bottom. So it's 160. But it's only the bottom alone as a thickness. Can you imagine that the thickness is only at the bottom, down here. So you're subtracting 5. So the depth becomes 155 centimeters, become the depth of the box. You understand that? So the internal volume becomes the product of these 3 numbers. Product of those 3 numbers. Alright? This is centimeters. So the internal volume becomes the product of those 3 numbers. Volume internally then becomes 290 times 180 times 155, and that is supposed to work out to this value, 8091,000. 8091,000 centimeter cubed. All right, that's the question you're saying about understanding your gun. Let's research it. Okay. All right, so this is it. So it is 290 times 180 times 155. Good, exact. Next question says, that's internal volume. Next question says, calculate the volume of wood needed to make the trough. So the wood in the material is the external volume minus the internal volume. That's the wood. Right? So the wood that making up this is going to be the overall volume of everything minus the volume of the space inside. That's the volume of wood. So the volume of wood, here, the volume of wood becomes the volume external minus the volume internal that we just calculated. The volume external is the external dimensions. What were they again? There were 300, 190, and 160. 300, 190, and 160. 300, 190 times 160. That's external volume minus the internal volume is this 8091. 8091,000. That's what we're working on. Let's put that in. So it becomes 300 times 190 times 160. That's external volume, and then you subtract the internal volume of 8091,000. And it becomes 1029,000 cm cube. It's the volume of wood making up that trough. Alright? Volume of wood. So it becomes the external volume minus the internal volume. Next part says, Farmer Brown must pay the internal surface of the trough. Internal surface of the trough. So given that 1 gallon of paint covers approximately, so 1 gallon, let's write it down, 1 gallon covers 280,000 cm cube. Alright? Determine the total amount of paint in liters that is needed to paint the internal surface of the trough. So we need to know the total internal area of the trough. You can do it by just adding up all the faces on the trough, right? So look at it this way. You have two on the long side over here and over here, internally. You have two on the short side over here, and you have the piece at the bottom. Right? So in terms of total area, it's going to be two times the long side. The long dimension is 180 by 155. 2 times 180 by 155. That's one side. And then now we have this back and the other end inside here. That's 290 and the 155. You have two sides that are 290 times 155. You have the bottom, which is just 290 by 180, not including the height. And it's just one side at 1 times 290 by 180. That's going to give you a total surface area. Let's copy this down. That's going to give you a total surface area. This is a total surface area right now. Total internal surface area. And what is equal to? Let's write it out here. So it is 2 times 180 times 155 plus 2 times 290 times 155 plus 1 times 290. Put some plus on that. Yeah, times 180. I'm getting 147,680 centimeters squared. That's the total internal surface area. Centimeters squared. Let's double check that. Oh, I left off some things. 2 times 180. 2 times 180. It's not right. Let's check the numbers again. 2 times 180 times 155 plus 2 times 290 times 1. Stop talking. Hey. Stop talking. 2 times 290 times 155 and then 1 times 2 times 180. Alright, so that's 197,900 cm cube. That's the total surface area. 197 as the bottom alone. Huh? What is it? You have 4 sides, right? Internally. One over here, and one on the other side inside us, right? You get it? That's the 290 times 155, right? They have 2 other sides here, so one over there and one over there, so, right? Those are 180 times 155, right? And they have the bottom. The bottom is just, the bottom is going to be the product of these two lengths. Right? It's area you're doing. So this is the total surface area that is painted. 197,900 centimeters squared. And then now it says it is 280,000 per gallon. So to know how many gallons it's going to need, you're going to divide this now by 280 gallons, don't it? By this amount of safety, right? To know the number of gallons that you need. So number of gallons is going to be 197,900 divided by the amount that he uses for 1 gallon. 280, 1, 2, 3. Write that out, that's the number of gallons that he's going to need. So it's 197,900 over 280, 1, 2, 3. It's going to need 0.696 gallons. Not a whole gallon is going to need, because this is actually less than 280,000. The question tells us that the one answer in liters, and 1 gallon is this amount of liters. So to convert this to liters, we just need to multiply by 3.79. See that? So this equals 0.696 times 3.79, and answer is going to be in liters. So we multiply this value as it is by 3.79, and so he is going to need 2.64 liters. That's the answer here. Yes, I said question like this all the time, so get comfortable with it. It's not difficult. Just go and do it over. Just go and do it over. Do it over. They said question like this all the time. This trough and all them kind of stuff. Get familiar with it. Come, number 5. Let's go. 5 to go. This question says, this is statistics. 100 students. 100 students. 100, Mr. Shaw. 100. 100 students were surveyed on the amount of money they spent on data for their cell phones during a week. The table below shows the result as well as the midpoint for each class interval. So that's giving us the midpoint, helping us. It says, using the table, determine the modal class for the amount spent. The modal class is the class that matches the highest frequency. See it here, so? That's the modal class, highest frequency. So that's 70 to 80, and that is in dollars. Put it on in dollars. That's the modal class. Put dollar sign on it. That's the modal class right here. This one of the highest frequency. 1 free mark that. Next one. Calculate an estimate of the mean amount spent, giving an answer to 2 decimal places. So we need a way to sum the amount spent in a sum column. So I'm going to put in a sum column, which is a F times X column. Alright, so we need to multiply this F by X. Remember, using the midpoint to represent the group. Remember, I say it's just an estimate we're doing. It's an estimate because the data is group. We don't know the actual amount spent by the students. So first is 7 times 55. 7 times 55, that's 385. And 11 times 65. You could actually multiply all of these one time and divide by 100 if you want to make. So that is the one sum. This time, this plus this time, this plus this time, plus that time, that plus that time, that. And then divide all of that by 100 if you want to, right? But most time we do it in the table, use the table. 11 times 65, that's right here. 11 times 65, that's 715. Then this one is 31 times 75. 31 times 75. 31 times 75. 2325. Then we want 29 times 85. 29 times 85. That's 2465. Then we want 22 times 95. 22 times 95. That's 2090. I'm going to do the sum of FX, which is the sum of total money spent out of all of these. Alright, so it's 385 plus 715 plus 2325 plus 2465 plus 2090. That's 7980. The total money spent approximately by all 100 students. Therefore, the mean, the estimated mean, is the sum of the sum column divided by the number of students, which is $7980 divided by 100 students. And that is 79, that becomes $79.80 is the mean amount spent, average amount spent by the students. Very good? Alright. Next one. Damian reported that the median amount spent is $84. Briefly explain why Damian's report is correct. So what you have to do is find out which class interval the median student would be. That's the 50th student. If it's 100 student, the median corresponds to approximately the 50th student, right? And the data is good. So you need to be able to count up and say where the 50th student would be. You're counting the students up here until you find the 50th student. So if you were to put in a little counting column, count, which is your cumulative frequency, count, which is your cumulative frequency, adding up frequency. In the first group, you have 7 students so far, 7. They add 11 more students, you reach 18. They added 31 more students. 18 plus 31 is how much? 49. So the 50th student is in here, so don't it? 50th student is inside us, so the 50th student must be here. So 50th student is actually the first one in this group. I finished 49 with all of these. I finished 49 today. So the 50th student is the first student in this group. Remember, you don't know what they actually spent. So any value that is between $80 and $90 is a good estimate for the median. You don't know the values. You just don't say that value inside there. So the 50th, you don't know what they actually got, how much they actually spend. You just already spend more than 80 and less than or equal to 90. 84 is in that range. You understand that? Good? So 84 is a good estimate for the median. Can be that. 50th student is there. Let's explain why. So I'm going to tell them that the 50th student is in the 80 to 90 class interval. So I'm going to say the 50th student is in the 80 to $90 interval. Where $84 lie. $84 is in this interval. Therefore, $84 is a good estimate. Remember, the median corresponds to the 50th student. You understand me? The median corresponds to the 50th student. And the 50th student is in that class interval. And 84 is in that class interval. And that is it. Next question. It said the two-way contingent that below is information on the mode of transportation to school by 100 students. Right? It says complete the table and insert the missing value. Now, a two-way table is that you can sum the values this way, and you also sum the values this way. Two-way table. All right? So everything must be consistent. So for example, these two values must give you 23. So this value is 23 minus 15 right here. So 23 minus 15. That's 8, right? So this is 8. And here again now, these three values must give you this 48. So this value then becomes 48 minus these two. These two are up to 29. 15 and 14 is 29. This value is 48 minus 29. 48 minus 29, that's 19. This value is 19. And these two values add up to this. That's 37, right? That's 19 plus 18, 37. They can compete by checking if these values now add up to 100, just to confirm. Make sure everything all right. 23 plus 37 plus 40, 100. So you know everything right. Oh, we don't put in this one yet. So this one now is that these two values must give you 100. So this value becomes 100 minus 48, which is 52. And these values must also now add up to 52, which you can also double check just to make sure. That's 8 plus 18 plus 26, 52. So you know everything. Alright? So we have completed the table. Next one says, a student is selected at random. Once they say a student, it means that you're selecting from 100. You're selecting from 100 because they say a student. So a student is selecting from 100. Because they say a student, it is from 100 is selected. What is the probability that he or she was driven to school? So the total number of students driven to school is 40, don't it? Out of the 100. That's 40 over 100. 0.4 or 4 over 10 or 2 over 5. Want to go to that? If you put the decimal, they give you the marks there. Right? That will be 0.4, right? Next one is now say a girl is selected. So this is from how many girls is there? It's selecting from how many girls? So the girls here are selecting from 52 girls. So we select a girl is selecting from 52 girls. It says what the probability is that she did not cycle. So if she did not cycle, it means that she walk or she drive. Did not cycle means walk or drive. Walk or drive, Mr. Shaw. Walk, but it's not coming in at all. Or drive. That's what did not cycle means. So you have to do the sum of the walk and the drive on the girls. So this probability becomes 8 plus 26 out of the 52. But understand that? But understand that? So 8 plus 26 is how much? 34. Walk and the drive. 8 plus 26. So about 26. So it becomes 34, right? 34 over 52. 34 over 52. And that is 17 over 26. 17 over 26. Answer question done. But I write that 4 to go. Let's go. Number 4. Functions. I see functions. For the geometry. Let's go. This question says the diagram shows line 1 and line 2. The equation of line 1 is this. This is line 1 equation, which I've shown on the diagram. It says the line 2 passes through 0, 5. That's the y-axis intercept. So this is the C value right here. That's a C value on line 2. C equal negative 5. Alright. And it's perpendicular to line 1. So then perpendicular means that the yes? Huh? Put as percentage. They're going to give you the marks in about usual probability is given as a fraction. But if you put a percentage, they give you the marks still. But let's give it as a fraction. Alright, so the lines perpendicular, so they have negative reciprocal gradient, right? So whichever one you know, you flip it and change the sign of the next one, right? Question says, express line 1 equation in the form y equals mx plus c. So write in the form y equals mx plus c, make it y the subject. What is it? It is x plus 2y equals 10, right? Yes, I want to make y the subject. So I subtract x first. You're going to get 2y equals minus x plus 10. And I'm going to divide 2 by 2 or multiply 2 by a half. You're going to get y equals minus half x plus 5. That's it. Y equals minus half x plus 5. That's it in the form y equals mx plus c. So the gradient of this line is minus half. That's the gradient of line 1 is minus half. Still the gradient of line 1. The gradient of line 1 is this value. The c value here, so minus half. The m value I mean, minus half. Just state it, that is it. We have it in the form y equals mx plus c now, right? Gradient of line 1. Next part. And determine the gradient of line 2. Now, line 2 was a c value of negative 5. And gradient of line 2 is minus 1 over gradient of line 1 because they're perpendicular. Remember? Line 1 was perpendicular to line 2. That's why we have this negative reciprocal gradient. Line 1 gradient. Well, at least the thing not cutting off. So we waste my money buy this thing. I mean, I tell you, if you have to care back. Imagine my hotspot better than it. Ridiculous. Never give me a problem, Mr. This, I don't know. The problem is that, but at least it's not cutting off. Anyway, let's continue. Alright, so that is it, right? Two lines perpendicular. And so the product of the gradient is equal minus 1 using negative reciprocal gradient. So remember, the gradient of this line is minus half. You flip it and change the sign, right? Flip it and change the sign. This gradient becomes positive 2. Gradient of line 1 is minus half. You flip the minus half and change the sign, it becomes a positive 2. So the gradient of the line 2 has this gradient with this c value. So we're using y equals mx plus c for line 2. And we're talking about line 2, we'll put 2 on this and 2 on this, right? So line 2. So the equation becomes y equals 2x and the plus c is minus 5. Minus 5. Y equals 2x minus 5. Is the equation of line 2. Easy question. What go to that? But alright? Alright. Next question. Part B is functions. Nice and easy. Give us f function and g function. I want f of 9. F of 9 means we're going to put 9 in the f function right there. So that becomes equal to 1/3 of 9 plus 4. 1/3 of 9 is 3 plus 4. 3 plus 4 is 7. Nice and easy. Next part, I want f of g of negative 3. Remember, f of g of negative 3, we're going to do the g of negative 3 first, right? So I'll put the negative 3 in the g function first right here, and then put the result in the f function. So it becomes f of, I'll do the g of negative 3 first in here, g of negative 3. So put the negative 3 in this. So it becomes 3 times negative 3 over negative 3 for this x, negative 3 for this x plus 1. That becomes f of negative 9 over negative 2 become 9 over 2. 9 over 2. What go to that? 9 over 2. Then f of negative 9, f of 9 over 2, me put in 9 over 2 in this again. So it becomes 1/3 9 over 2 plus this 4 plus this 4 plus 4. That becomes 3 over 2. This is 3 over 2 because this cancels at this 3 times. So you get 3 over 2. 3 over 2 plus 4. This 4 is same as 8 over 2. So it becomes 11 over 2. 11 over 2. 4 is same as 8 over 2. 11 over 2. Next part. It says terminal value of x if g of x equals 5 over 2. So we're going to put this expression for g of x equals 5 over 2. That's 3x over x plus 1 put equal 5 over 2. 3x over x plus 1, that's the g of x, put it equal 5 over 2 and solve. Put it equal 5 over 2 and solve. We're going to solve this by cross multiplying to get rid of fractions, right? Multiply this up here, multiply that up here. When we multiply the 2 up here, it becomes 6x equal, multiply the x over here with the 5, it becomes 5x plus 5. But understand that? Take this 5x and subtract over here, so 6x minus 5x is x equals 5 is the answer. X equals 5. Nice and easy. But get that? Good. Next question. Question done. Next question, number, what next? Number what we just do? 3. 2 to go. No, 3 to go. Number 3 now. Transformation and so on. Let's go. Right angle triangle. Question said, diagram below shows triangle PQR in which that angle there is 62 degrees up here and the angle right here is 90, so we can find this one. Those two are complementary, right? This one down here, if we want it, is 90 minus that one. And they say that the hypotenuse is 11. Good. They say what's inside of PQ, PRQ? Oh, they want this angle for true. Alright? That becomes equal to 90 minus 62. What is that? 28 degrees. What I agree with that? These two angles are complementary angles. They add up to 90. But this one is already 90. So this is 28 degrees right here. So 28 degrees. Next part says we must calculate the length of RQ. That's this side. So we're calculating the length of that side. Depends on which angle we're going to use under consideration. If we're using the 62 degrees, then that is the opposite. If we're using the 28 degrees, then it is the adjacent. Your choice. Let's say we're using the 62. Using the 62, then this is the opposite to the 62. And put it in red. Mark it in red. Let's say we're using the opposite, the 62, then this is the opposite, and this is the hypotenuse, right? Opposite and hypotenuse is sine. We're going to use sine of 62 to get this side. So we're going to say sine of 62 degrees equal the opposite side RQ over the hypotenuse of 11. See there? Opposite side RQ over the hypotenuse of 11. It's RQ the one, right? Then to find RQ, we take the 11 and multiply it over here. So the RQ becomes 11 times the sine of 62 degrees. Put that in the calculator, RQ equals how much? Who did it? Huh? 9.7 what? 1 centimeter. Put the centimeters on it for me, please. That's RQ. Always give your answer to 3 digits, 3 significant figures when you don't tell you how accurately you want the answers. Next question. The diagram below shows 3 triangles X, Y, and Z on a square grid. X, Y, Z. Alright? So some transformation taking place. Question says, triangle X is mapped to triangle Y by a reflection. Say the equation of the mirror line. Triangle X is mapped to triangle Y in a line. The mirror line is going to be equidistant between them. So the mirror line is this. That's the mirror line. The mirror line is the x-axis, don't it? The question never asks for which line it is, they ask for the equation. See? Equation of the mirror line, which is the x-axis. You can't say x-axis and x-axis, not an equation. Equation of x-axis is y equals 0. So this you have to write for your answer. See that? Mirror lines the x-axis. The map for the equation, you have to write y equals 0. The equation of the x-axis is y equals 0. So you cannot just write x-axis, guys. They're asking for the equation of the mirror line. That's what they're looking for 1 mark. So if it's the x-axis, you're not getting the mark. That's for the equation of it. Equation of x-axis is y equals 0. Next one. Describe transformation which maps triangle x onto z. X onto z. Let's look at it. X onto z. This one onto this one. So clearly we have a rotation, right? It's a 90-degree rotation. How do we know it's a 90-degree rotation? Because this side which was horizontal, this side which was horizontal is now vertical. See that? So turn up this way by 90 degrees. So we know that 90-degree anti-clockwise rotation. About where we need to find the center of the rotation now. So we know it's anti-clockwise, 90 degree already. We need to find the center. The center normally is the origin in these questions. You're going to just test and see this is the origin right here. Test and see. So if we test this point, if we rotate this point 90 degrees this way, it's coming down to here. So yes, that match it, right? Let's try this one now. Rotate this point. So like it from origin, like I take this L up to the point. If you rotate that L up to the point, this piece that is on the x-axis is going to go on the y-axis up to here. This piece at the head of it is going to come over to here. So yes, that confirms it. This L-looking thing, if you rotate it 90 degrees up so, that's where it's going to go. So that confirms that yes, center of the rotation is the origin. Alright? So the anti-clockwise 90-degree rotation about the origin this one is. An anti-clockwise 90-degree rotation about the origin. Now remember, because you're describing a rotation, you have to give the 3 components of rotation. Angle, direction, and center. You cannot just say the rotation. You cannot just say the anti-clockwise rotation. You have to also state the center. So you have to tell them everything. So it's an anti-clockwise 90-degree rotation about the origin. Anti-clockwise 90-degree rotation about the origin, which is 0, 0. So I'll give you 3 components. I'll give you the angle, the direction, and the center, and the name. The name and the 3 components. Angle, direction, and center. That's it. Alright? Next part now says, on the diagram, translate triangle Y minus 7, 1. Remember, minus 7, 1 means 7 to the left and 1 up. 7 to the left, 1 up. So moving the triangle, 7 to the left, 1 up. It's triangle Y we're moving. Triangle Y, where is it? 7 to the left, 1 up. So this triangle we're moving. Triangle Y. Let me take this off. So you need to move 1 point and then draw by the same shape around the 1 point. Let's say we're using this point down here. So this point up here. So 7 to the left, 1 up. Check the scale of the graph. So each of these grid is 1 unit vertically. Each of these lines horizontally is a unit. So we're going 7 to the left at this point. 1, 2, 3, 4, 5, 6, 7, 1 up to here. So this point is coming to here. And it will draw by the same shape around it. Same shape. So this length to draw about this length the same, which is 1, 2, 3, 4, 5, 6 long. 6 units long. 1, 2, 3, 4, 5, 6 units long. Then this is 2 down, 2 back. 2 down, 2 back to here. That's where that point is, like this. And then complete the triangle like that. That's it. Let's must label something. Don't. Always must label something. Label it V. Label it V. Label it V. Alright, that's your V. What else I want us to do? It says on the diagram, enlarge triangle O, center O, enlarge triangle X, center C00. That's the origin. That's the origin, guys. That's origin. So once you have an enlargement with the origin, you can use the enlargement matrix. Scale factors are half. The enlargement matrix is half, 0, 0, half. Remember the enlargement matrix is K, 0, 0, K. About the origin, this case the K is a half. About the origin. Good? So what this does, it takes a point, x, y, and it half the coordinates. It's going to take it to half x, half y. Because the scale factor is a half. So it's going to move it half towards the origin. Half x, half y. So you can just half the coordinates. Label it W. Which one we're doing? X. We're doing x. So let's do that. Let's half the coordinates. X. So this one. We're just going to half the coordinates to see where it's going to go. Half the coordinates of the vertices. Let me use a different color for this one. So this point is 4, 4. Half of 4, 4 is 2, 2. Right here. This point is coming right here. This one is what? 6, 2. Half of 6, 2 is 3, 1. 3, 1. 3, 1. Right here. 3, 1 is right here. And this point is 0, 2. 0, 2. Half of 0, 2 is 0, 1 right here. So this point is coming right here. So this is your image triangle of the enlargement right here. Simple as that. Just half the coordinates. You put in the construction lines, it's gonna be this. See here? This one come to that, this one come to that, and this one go to that. See? Those are your construction lines. Then someone label the triangle what? W? Label it W. W. That is it. So it's using enlargement matrix. Half, 0, 0, half. Since scale factor is half, half the coordinates. Alright? That is it. Nice and easy. That question done. Number 2 next. 2 to go. 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 Alright. Two quantities n and t are related by this formula. It says find the value of n when t is 49. Simple. Take the 49 and replace the t there, so you get n equals the square root of 49. Everybody know the square root of 49 is 7. Make t the subject. To make t the subject, we're going to square both sides, don't it? So if you have n equals the square root of t, we're going to get a square root here, so square both sides. Square the side here and square the side here. The square seems to wipe out that square root. And so we end up with t equals n squared. Must make it the subject, turn it around and write, i.e. that is t equals n squared. 3 marks them there now. 3 marks. So you can't tell me so you can't get 30 on this. Mad. Let's go. It says Ali is X years. Jim is 5 years older than Ali. So Jim is 5 years older than Ali. There's a right expression in terms of X for Jim's and Chris's age. Alright. So Jim is 5 years older, right? Than Ali. So Jim is X plus 5. Them say Chris is twice as old as Ali. Chris is twice as old as Ali. So Chris is 2x there. That's all? Twice as old as Ali, because Ali is X years. Easy. He says in 2 years' time, that are 2 years more, right? In 2 years' time, all right. So in 2 years' time, Ali is going to be X plus 2. Ali, let's write them out. 2 years' time, adding 2 to everybody's age, right? So Ali is going to be X plus 2. Jim, in 2 years' time, is going to be X plus 7. And Chris, in 2 years, is going to be 2x plus 2, right? Just writing them down in 2 years' time. Those are going to be the ages, just to make sure. In 2 years' time, the product of Ali's age and Chris's age will be the same as the square of Jim's present age. All right, let's make sure now. In 2 years' time, the product of Ali's age here, which is x plus 2, product that with Chris's age, where Chris is this, 2x plus 2, taking the product, 2 years' time. Come on, that device, plus. This is Ali's age in 2 years' time, that is Chris's age in 2 years' time. It's going to be equal to the square of Jim's present age. Jim's present age is this. It's going to be equal x plus 5 squared. But understand that. But look at that. Show that this work out to that equation. Show that the equation that represents information given. So we're going to take this equation now, simplify and reduce it. It's going to come down to this. Let's go. Expand this first. This is x times 2x is 2x squared. X times 2 is 2x. Then 2 times 2x is 4x. Then 2 times 2 is 4. Equals, expanding this perfect square. Remember, expand a perfect square, you get 3 terms. First term squared is x squared. Then twice the product of a 2. When you multiply these two things first and then you double it. When you multiply them first, you're going to get 5x. You double it to 10x. Then the second term squared, 5 squared is 25. That's what we're getting. Let's simplify now. Bring over this x and subtract from that 2x squared. Take this x squared and bring it over and subtract from that 2x squared. We're getting x squared over there. Then this and this is 6x. Take that 10x here and subtract over there, sir. 6x minus 10x is negative 4x. You have this 24 over here, so I have 25 over here, so 25 come over here, so and subtract. 4 minus 25 is negative 21. And that's all equal to 0. Same thing them up. Shown. Shown. I'll put another thing, something nicer. Quite easily brushed aside. Soft. Soft. With a capital T. Enjoy the maths now. Calculate Alice's present age. Remember, Alice's present age is x, don't it? X times 1, don't it? Calculate Alice's present age. Alice's present age is x. So we need to solve this for x, right? This can factorize, you know, because 3 times 7 is 21, don't it? And the difference between 3 and 7 is 4, don't it? So this can factorize. Let's factorize this. Hello. Talking is now so good for the online thing. Relax now. Factor of the x squared is x and x. Factor of the 21 is 3 and 7. Hello. Signs are different. If the greater product, the minus sign. Greater product is the larger one. How many I tell you to stop it talking? This becomes a negative, that becomes a plus. See, the far product is negative 7. The product is positive 3. Negative 7 plus 3 is negative 4, the middle term. So those are the factors. So you're getting x equal negative 3, x equals 7. This negative 3 is not valid, guys, because somebody each can negative. So this is not valid. See that? So this is the answer, 7 years. 7 years. 7 years is the answer right here. Hello, hello, stop talking, man. I'll go outside. What do you mean last? Which part is last? Huh? Just factorize this, my boss. Factorize this. If x plus 3 equals 0, then x then equal negative 3. When the product of these two things equals 0, either this equals 0 or this equals 0. So, think of pass this now, man. That's fine. It no matter which method you use, quadratic formula factorization still correct. You have the option of quadratic formula and factorization when you're solving a quadratic equation, your choice. You still have to learn how to factorize. Still have to know how to factorize. Anything else? Question done. 9 marks. 1 to go. 1 to go. 1 to go. Number one. Calculator question. See it here, mom? Use a calculator good, right? About that foolishness. Use the power of your calculator. You can't have a good calculator and not type in the thing as it appears here. The marks of the word that all put it in the calculator, see? Using a calculator or otherwise, put it in the calculator as it appears there. Ready? Mixed number. 1 and 4 over 7 divided by 4 over 7. 1 and 4 over 7. Divided by, oh, you tell me the answer. 2/3. Then we are subtracting another mixed number. 1 and 5 over 7. What you say yet? 9 over 14 is what you get. Anybody get 9 over 14? Oh, alright. Alright. Let's go. Next question. Come on, you can't get him something wrong for the exam. No. Foolish. I don't want you to get it right. You can't teach this. Let's go. Next question. When Megan started working, she was paid $85 each week. After 6 months probation, her pay was increased by 20%. Means that she's getting 20% more on her pay. How much was she paid after? How much was she paid each week after the increase? She's now being paid 120%. You do have to work on the 20% first and then add it. If you increase up by 20%, the new value is 120%. If it was a decrease of 20%, then the new value would have been 80%. Taking off 20%. You need to work percentages that way. So the new value is 120% of what she was getting. Simple as that. Do the mathematics the easy way. It's only 1 mark for it. 120%. 120%. 120% times 85. $102. She now getting. Get that wrong again. $102. You get him something wrong, my boss. People in a prep school, I get them right, you know. High school, in a fifth form or fourth form, you still must get it right. Come on, man. Can't get anything wrong, man. Let's go, next question. If you calculate 20%, you can add it to the original value. But waste of time to do that. If you learn to do percentages this efficient way, especially for the multiple choice paper. Let's go. Next question. In 1965, the population of country A was this, 2,714,000. In 2015, the population is now this, 3,663,900. Write the population in 2023 in 2015 in 3 significant figures. Remember, the size of the population can't change, the magnitude of the population can't change, even when you write it in, even when you correct it. If it is in the 3 millions, it must still come back in the 3 millions. Just like them want 3 significant figures. So 3 significant figures is these 3 figures. Right? This value, if this value was greater than a 5 or more, it would increase this to 1 by 1. But it is actually less. So what you do now, you write back this magnitude and you replace all of these with zeros so that the size of the number stays the same. Alright? So these are the 3 significant figures. So the answer for this in 3 significant figures is 366. But all of these now become 0, 0, 0, 0, 0. Such that the size of the something is still 3 point something million, same way. You can't write 366 as your answer. 366 can't represent 3 million. Don't make no sense. You understand? That is it. That is it, just 3 significant figures. So they made 3 significant figures. Next one. Write the population in this 1996 in standard form. This is the value that we want to write in standard form. You want the decimal point right here. 2.7 million. Right? So it's a big number. So you're going to have 10 to some big number, 10 to the 6. So that's, if you want to work it out, 2714000. The decimal point at the end. When they don't show it, you want it to come right here. You have to move it 1, 2, 3, 4, 5, 6 units to the left. 6 places to the left. So, is that order like you divided it by 10 to the 6, or you multiply by 10 to the minus 6 to move it to the left? The decimal point that is here. So you can say divided by 10 to the 6. That will move it for you. This will move it for you to divide it by 10 to the 6. But to balance back out this division by 10 to the 6, you also have to multiply back by 10 to the 6. So you have not changed the number, you have just adjusting how it appears. So this calculation you know will move the decimal point for you and put it where you want it. 2.714. I don't need to put these other zeros after the decimal point. Times back this 10 to the 6 times 10 to the 6. That is the answer right there in standard form. Alright, you must have the decimal point after the first non-zero digit in standard form. After the first non-zero digit, you want the decimal point. Now, next one. Determine the percentage increase in the population. So the percentage increase is the increase over the original value times 100 as a percentage. The increase over the original value is the increase on the original value. That's about the percentage increase, is increase on the original value. So the increase is this value minus this value, and dividing that by this value, multiplied by 100. Let's work it out. So it's a 3663,900 minus the original value is this 2714,000. That's the increase over the original value 2714,000. I multiply that by 100 to get the increase as a percentage. So the increase over the original value times 100, that gives you the percentage increase. So putting this in the calculator now. If you want to work out the increase separately by itself and then put over the original value, fine, but you can just do one calculation like I have on the screen. So the increase, which is 3663,900 minus 2714,000 over 2714,000. Multiply that by 100, you get 35%. 35% increase when you multiply this by 100 to get the percentage. What you get? Good? 35%. Next part now says, ratio of teachers to male students to female students in a school is 3 to 17 to 18. If the total number of students is 630, determine the number of teachers in the school. All right, I'll do this question in a nice, easy way and show you. All right. So, all I like to do ratio question and teach ratio question is to recognize that a ratio can be multiplied or divided by any constant value or any constant unit of measure. You can also extend the ratio that they give you to capture the information that you want. So watch this now. Watch this now. So it says teachers to male students to female students is in the ratio 3 to 17 to 18. And they are giving us a total number of students. So because they give me the total number of students, I'm going to extend the ratio to show, let me just call it students for the total. Students. In the broken down, because the ratio is just a broken down comparison of the actuals. You know. The total number of students in the broken down comparison of the values or the total of the numbers is 17 plus 18. 17 plus 18 is how much? How much? 35. So in the broken down comparison of the values, the number of students is 35. I can take this ratio and build it up back to show what the actuals are. So I'm going to put a line for the actuals. So this is the broken down comparison. I'm going to put in the actuals now. Actuals down here. The actual that we know for the students is that the actual is 630. 630. So the thing is, what do I multiply this by for to reach 630? I can know what I multiply by dividing. So 630 divided by 35 is 18. So if I multiply by 18, I will get what the actuals are. So all I need to do now is multiply the rest of the ratio by 18. And I will know what the actuals are. So the actual number of teachers then is 18 times 3. Multiply everything by 18. Multiply the ratio by 18 to get the actual for the students. Then to get the actual for the teachers, I need to multiply this by 18 as well. So multiply this by 18. 3 times 18. 54. So the number of teachers is 54. If I want to know the number of male students, I multiply this by 18. If I want the number of female students, multiply this by 18. That's all I need to do. So 54 the number of teachers. Number of teachers is 54. 3 times 80. That is it. And that is that. Is that. Alright guys. So look here. Hold on, relax now. So remember now, we're not having in the class. We're not having a class until Sunday. But I'm going to be sending work for you to do. So when I send the work for you to do, make sure you do it. Because it is what I'm going to be addressing on Sunday and on Monday. Alright? So do that for me, please. Alright. See you again on Sunday and Monday. Bye everybody. I give me a problem because share it. Give me a problem.